Afternoon and good evening, Bearcats. Okay, we're in 5.3 and this is solving trig functions. So now we're going to take all of our simplifying skills that we have developed and we're going to take the algebra skills that we have known coming into the course, and we're going to take our what we've learned about trigonometry and the unit circle and special triangles and values versus angle rotations, and we're going to learn to solve our equations. So we're going to kind of take all of this together and put together. The first one, kind of we work, is a little different than the rest that we'll work today, but it just helps prove what we're doing. The question is x, when x is pi over 12, or when x is 5 pi over 12, are these solutions? So in a minute after this problem, we're actually going to be finding the solutions. This gives you the solution, and you're just verifying it's true. The equation that they're giving us is, so this is a way to check your answers if you knew the answer. In this case we do. So 3 tan squared times 2x minus 1 equals 0. First we're going to simplify things a little bit before we plug in x to find out if it's true or not. So the first thing we're going to do is move the 1 over and then divide by 3, and when we do we get tan squared 2x equals 1/3. After that, we're going to go ahead and substitute in our values to see. We're going to start by substituting pi over 12. So we would have tan squared, and then we would have 2 times pi over 12 equals 1/3. That would be our pi over 6, so we have tan squared pi over 6 equals 1/3. All right, at this point, we're trying to figure out at pi over 6, what is the value of tan? So tan squared at pi over 6. So you have to imagine your little chart, and at pi over 6, you know the tan value is the square root of 3 over 3. And that just comes from your chart or your special triangles. However you figure that out. In my class, I know that we've actually memorized the special triangle values for our quadrant 1, and then are applying that in the other quadrants. So we're going to say that we know that is the square root of 3 over 2, and we're going to square it because this is a squared term. So we have the square root of 3 over 2, and we will have to square that to see if it is equal to 1/3 to prove that that is a solution. The square root of 3 is 3. The square root of 2 is, square root of 3 over 3. The square root of 3 is 9 equals 1/3, and in fact 3 over 9 is 1/3. So move it over here. 1/3 does equal 1/3, so go Bearcats. For the sake of this video, I'm going to explain to you that also 5 pi over 12 would also, once you plug it in, will also give you a correct answer because we're just in a different quadrant, and it will end up being also the correct answer. So we're going to move on to the next example, so you can plug that in as well. Let's move on. Okay, number 7. All right, now we're going to actually start to solve. The equation we're given is 2 cosine x plus 1 equals 0, and we're going to begin solving. Since there's just one term and a constant over here, we're going to go ahead, and this is where the algebra skills come in. When we're solving, we're moving everything away from what we're trying to solve. So we would subtract the 1, and then we would divide by 2. When we subtract the 1, it would be a negative, and then dividing by 2 would make it a negative 1/2. If you're caught up in this section right here, then you need to, slow it down and look at what we're doing. So I'd move the 1 over, and then I would divide by 2. So I will end up with cosine x equals a negative 1 over 2. And now we can just solve for that. So we have to imagine over here on our little chart, we have to imagine where cosine is negative. Okay, now remember I told you recently that we're going to get where we're having more than one solution because we could be negative in more than one quadrant. Well, we know the little all surfers to California thing. We know that that means cosine would be positive in the first and the fourth, therefore it would be negative in the third and the second and the third. So now we want to talk about our reference angles. So now you're going to think, so the first thing you think is where is cosine negative, and we took care of that. And the second thing is where, or what reference is cosine, at what rotation is cosine 1/2. So if you think about your chart, you know that cosine's 1/2 at pi over 3. So pi over 3 is our reference. So our reference angle is pi over 3. Now, be really careful. That's our reference. So remember, at the x-axis, this would be 3 pi over 3. We did this at the very beginning of the year when we learned our unit circle. So if we move back one, our angle would be 2 pi over 3. And if we move forward to the, and we're not really rotating backward, we're just going backwards, thinking backwards. Our rotation would be forward into the, would be to the next quadrant. So from 3, we would add 1 to that, and we would have 4 pi over 3. And that would be our 2 if we were restricted. And so this is if our restrictions go from 0 to 2 pi. So if our theta is from greater or equal to 0 and less than 2 pi. So that's for a restricted value. If we were not restricted, then if we went here and we went all the way back around the circle to here again, that would also give us a correct answer. Or if we started in the third quadrant and we went all the way around and we went back, it would also give us that answer. We did that before when we did our graphs, and we added something to that. So I'll go ahead and show you that. So if you do 2 pi over 3, you could say plus increments of pi, so n pi. And you could say 4 pi over 3 plus increments of pi, n pi, and that would also be your answer if there was no restriction. Okay. All right. I think a lot of our equations will have restrictions. Let's move on to the next problem. All right. This is number 14, and we have 3 tan squared x minus 1 times tan squared x minus 3 equals 0. And this one happens to be factored for us already. We have this factor times this factor equals 0. Think about quadratics when we factor them out to solve them. So all we're going to do is we're going to set each factor equal to 0 and solve. So we're going to have several sets of answers. So we're going to do this one over here and say it's 3 tan squared x minus 1 equals 0, and this factor will be tan squared x minus 3 equals 0. So we'll be solving both. We'll go ahead and work on this left side first. We'll move the 1 over, will be positive and divide by 3. So we will get tan squared x equals 1/3. At that point, then we need to go ahead and get rid of the square. So when we do that, we're going to square root this side, and we'll square root the top and the bottom on this side. Were we an artist? I believe we were, so we will need to add our plus or minus sign. So on this side, we get rid of the square, and so we're going to end up with x. We're trying to solve for x, or that could be theta if that helps you. If you prefer that to be a theta, that's what we're solving for, is the angle. And that's going to be equal to positive or negative. The square root of 1 is 1. The square root of 3 is the square root of 3. We will rationalize the denominator. That will help us a little bit, and we'll end up with the square root of 3 over 3. I'm crossing that out just because I reduced it. So we have positive or negative, square root of 3 over 3. All right, here's the first time this has come up for us. Let's think about this. This was tan theta. Where is tan positive? Tan is positive in the first and the third. Where is tan negative? In the second and the fourth. So we're going to have 4 answers here. We're going to have 4 answers here. So now we just need our reference angle. So we're going to think about our reference. You're going to think about your chart. Okay, think about your chart. And on your chart, where is tan the square root of 3 over 3? Think for a minute. Hopefully you recognize it's square root of 3 over 3 at pi over 6. So our reference will be pi over 6. And then that means this is 6 pi over 6, and this is 12 pi over 6. So if we're back one, it's going to be 5 pi over 6. So our answers here will be theta, or x, equals, whichever you like to call it. I usually call it x, but know that it's the rotation, equals an angle rotation of pi over 6. If this is 6, back one would be 5 pi over 6. Forward one would be 7 pi over 6, and from 12 back one would be 11 pi over 6. So those are my answers for this factor. Now let's talk about this factor. Over here we would move the 3 over, and we would have tan squared x equals 3. We will square root, and we have tan x, or tan theta, equals, and we were the artist again, plus or minus the square root of 3. Well, we just figured out plus or minus means usually we're in all the quadrants. Tan will be positive first and third, negative second and fourth. So we are going to be in all the quadrants. And now we just need to know the reference. So the reference at square root of 3 is pi over 3. This would be 3 pi over 3, and of course this is 6 pi over 3, and that helps you figure out where you are in the quadrant. So your solutions for x this time on this side will be pi over 3, and back one would be 2 pi over 3. Forward from there would be 4 pi over 3, and back here would be 5 pi over 3. And those would be your answers. So this time we have actually 8 possible rotations that would make this equation true. All right, go Bearcats. This may be where you want to pause and take a look at what we did. So we're combining our trig, our simplification, and our algebra skills. You are becoming marvelous mathematicians. All right, here we have secant squared x minus 1 equals 0. So let's take a look at this one. This time we would move the 1 over and we would have secant. This is a reciprocal of cosine. So we have secant squared x equals 1. The next thing we're going to do is take a square root. We weren't artists, so we're going to have secant x or secant theta equals positive or negative 1. All right, now we have to think. Over here, remember we do a lot of thinking in this class. So we're going to think secant is 1 when cosine is 1, because the reciprocal of 1 is 1 over 1, and the reciprocal is 1 over 1. So whenever cosine is 1, that's when secant is 1. So think about your little chart, and we know we have 1, 0, 0, 1, negative 1, 0, 0, negative 1. So cosine is 1 right here at 0 radians. So x would be 0, and this time 0 is not the value, it is the rotation. We've not rotated at all. And we also have a negative 1 because it's plus or minus. It's negative 1 right here, which would be at pi. And that would be your answer. Go Bearcats. All right, we're ramping up here a little bit. We've got to solve this one, and before we can solve it, we need to do some simplification. One of the goals when we're solving is you really need to have the same trig function and not multiple trig functions. So not most of the time you're trying to get to the same trig function. So you have to kind of analyze this. So pause and analyze, or pause your brain, I should say, or your pencil writing, and take a look at your equation. I'm looking at this, and I don't know that I could do much about cosine making it become a sine, but I could take sine squared x, and I know I can rewrite that by Pythagorean identity into a cosine. So I'm going to do that. So I have this 2 out front, and I'm going to rewrite sine squared x as 1 minus. All right, and so we're going to switch sine squared x into 1 minus cosine squared x equals 2 plus cosine x. All right, so now we have all cosines, which is a big thing because now we can actually start to solve. All right, notice that I'm going to go ahead and distribute this 2. So I have 2 minus 2 cosine squared x equals 2 plus cosine x. I'm going to move everything to one side and set equal to 0. Notice this is a quadratic. When you have a square, it's kind of like quadratic when we do algebra. And so that's how you think of it, and we need to set it equal to 0 before we can solve. If I move the 2, this 2 to the left, it's going to cancel with this 2. So these are going to be a cancellation. So if I move this over, everything's going to be negative. I don't like this term to be negative, so I'm going to actually move the other direction. So I end up with a positive 2 cosine squared x plus cosine x, and that is going to be equal to 0. Nothing would be left on one side. All right, so at this point, now I can factor things out. I need to factor this out. I can factor out a cosine x, and inside I would have 2 cosine x plus 1 equals 0. And now I'm back to where I was in the last problem. I have 2 factors, and I have to solve both. So the first factor is just cosine x equals 0. That's going to be an easy one. And I'm going to do my other factor over here, give myself a little more room. I have 2 cosine x plus 1 equals 0. All right, so let's do this one first. Where is cosine 0? Well, we've already talked about that several times. I'm going to look at this. We know that this is 1, 0, this is 0, 1, negative 1, 0, 0, negative 1. Cosine is the x value. It's 0 here and here, which would be pi over 2 and 3 pi over 2. So that's the solution for this factor. This factor, I've got a little more work to do. I need to move the 1 to the left, which would be a -1, and I need to divide by 2. So I'd have cosine x equals -1/2. Okay, the first thing I'm going to do is, where is cosine negative? Cosine's negative in the second and the third. Remember, all surfers to California. So it's going to be in the second and third. Now I need to know my reference. So if I think about my chart, where is cosine 1/2? Where is cosine 1/2? In my little chart I've memorized, and cosine is 1/2 at pi over 3. So my reference is pi over 3, but I'm not in the first quadrant, so I'm going to write 3 pi over 3, and I'm going to write, or think, 6 pi over 3. All right, so 3 pi over 3, if I'm actually in the second quadrant, would put me at 2 pi over 3. And if I'm 3 pi over 3 at the axis, and I'm in the third quadrant, it's going to put me at 4 pi over 3. And those would be my next two solutions. So these are my solutions for number 24. All right, let's look at 28. We have secant x plus tan x equals 1. Okay, so secant x plus tan x equals 1. This is a little trickier. We're going to have to, this is probably the most difficult problem we'll work on today. We're going to have to get the same trig function, and right now we're not even close to the same trig function. So we're going to see what we can do to manipulate. We know we could rewrite secant as 1 over cosine x. And if you think about this, we can write tan to include a cosine, which is important. So we're going to write tan as sine x over cosine x. So at least at this point, they both have a cosine in them. All right, I'm going to make 1 over 1 so they look like a fraction as well. What we've also done on the left side is now they have a common denominator, so we can write it as one term. So we can write it as cosine x, and at the top it'll be 1 plus sine x. And that's equal 1 over 1. Whenever we get those situations, we can actually cross multiply to begin solving. So when we do that, you're going to end up with 1 times 1 plus sine x. And on the other way, we're going to end up with cosine x. So if we have those two situations, now we're going to work again trying to get one trig function. So I'm kind of stuck at this point. So one of the things that you can do, and I'm not sure you would know this if you had not seen it, we can actually square both sides. And we would do that because then we were going to get something in a Pythagorean identity that maybe we can switch from sine to cosine. So I'm going to take the left side and square it, and the right side and square it. Just to save us a little time, when we square this binomial, remember there's the shortcut. You take the first term and square it. You multiply through, so it'd be plus 2 sine x. You take the last term and square it, and that would be sine squared x. And that's going to equal cosine squared x. All right, we still have sines and cosines, but we also have cosine squared x, which we know we could write as 1 minus sine squared x. And if we do that, then we have all sines, so we're now down to one trig function, so we can start to solve. All right. This is a little lengthy. So at this point, we're going to combine everything and set it equal to 0. Oh, I don't know why I put a 2 there. This is a 1. Sorry. So our 1s on both sides are actually going to cancel out. And then we're going to move everything to the left and set equal to 0. When I move this negative, it'll become positive sine squared x, and we'll have 2 sine squared x plus 2 sine x equals 0. We're going to keep solving over here. All right, so at this point, I can factor out 2, and I can factor out a sine x. So I'd factor out 2 sine x, and then in my parentheses, I would have sine x plus 1 equals 0. I have two factors. Set each factor equal to 0. So I'd have 2 sine x equals 0, and I would have sine x plus 1 equals 0. I know I'm going a little fast on this, so you may want to stop and pause and kind of think through as you go through, or write it all down and then go back and watch it again, or watch it first and then write it all down, whichever is best for you to absorb this information. All right, so if I would divide by, on this side, if I divide 0 by 2, I still get 0, so I'm looking for where sine x is 0. Sine is 0. I'm going to write my little thing up here. 1, 0, negative 1, 0. Sine is the y value at 0 here at 0 radians and pi. So 0 and pi would be my solution on this side. Over here, I'd move the 1 over, and I would have sine x equals negative 1. Negative 1, sine is negative 1 down here at 0, negative 1, which is 3 pi over 2. All right, now, we think we found our solutions, but because we squared the original equation right up here in this step right here, we squared our original equation. Because we did that, we have to check for extraneous solutions. So we have to take our solutions and plug them back into the original equation to see if, in fact, they really work. Remember, secant is friends with cosine. And so I'm going to just do a check of our work. So if I check check 0, I would have secant at 0 radians plus tan at 0 radians equals 1, and we're going to see if that's true. Well, secant is friends with cosine. The reciprocal of cosine at 0 radians is 1, and 1 over 1 would be 1. So we'd have 1 plus. Tan would be y over x, 0 over 1, which would be 0. So tan at 0 radians is 0, and 1 plus 0 is 1, and in fact does equal 1. That one checks out. So that's a go Bearcat. Now, when we get to the next one, you're going to have secant at pi plus tan at pi equals 1, and let's see if that's true. All right, tan is also 0 right here. Secant at 1 or at pi is going to actually be a negative 1, so I think we're going to have a problem. And tan is going to be 0, and in fact that does not equal 1, so that's a no Bearcat. So that's an extraneous solution, and we're going to find that 3 pi over 2 is the same thing. So we have secant 3 pi over 2 plus tan 3 pi over 2 equals 1. Well, secant at 3 pi over 2. The reciprocal of 0 is actually undefined. That makes this an undefined term. You can stop right there. That is also an extraneous solution. So our only real solution is 0 radians for this problem. Kind of a crazy problem. All right, we have one more to go, and then we're done for today and solving. All right, last problem is something else we haven't seen before. It's not real difficult, but it is something a little different. We have sine 2x equals negative square root of 3 over 2. This is a multi-angle because we have more than 1, 2, or we could have a half. And what we're going to do is we're just going to solve normally as it was sine x, a negative square root of 3 over 2, and then we will end up dividing by this constant here, k. This means this is in the form of sine ku, and that's our constant right there, our cosine, ku, which is that k is our constant. So we'll be dividing by that constant. Okay, the first thing we're going to do is we're going to think again where sine is negative. All surfers to California. And we know that sine is negative in the third and the fourth. So we'll be in the third and the fourth quadrant, and then we're going to think of where is sine the square root of 3 over 2 off of your chart. So the square root of 3 over 2 for our sine value is going to be at pi over 3. So our reference again is pi over 3. So this is 3 pi over 3 again. This is 6 pi over 3 again. So here's what we're going to do. We're going to say 2x is equal to. If we're 3 pi over 3 and we're in the next quadrant, then we're 4 pi over 3. If we're 3 pi over 3, or we're 6 pi over 3 and we're in this fourth quadrant, then we're 5 pi over 3. So 2x is equal to 4 pi over 3 and 5 pi over 3. Now what we have to do is we need to divide by 2. Dividing by 2 is the same as multiplying by 1/2. So our x value will be 4 pi over 3 times 1/2. And our x value will be 5 pi over 3 times 1/2. So this is going to be 4 pi over 6, which reduces to 2 pi over 3. This will be 5 pi over 6. And these will be our two answers. Go Bearcats. All right, hopefully this is a good start for you, and a lot of practice will get you proficient, and you'll be good for your test on Friday if you're a pre-AP student, and a week from Friday if you're in regulars. I hope everything is going well, and I will see you later. Night or goodbye, Bearcats.